Alright, here we go. I got a little Star Wars action, a little Darth Vader holding up some linear function there, as I thought that kind of looked like some Star Wars futuristic type stuff going on. So we're talking about lines. So we've done this before. We're going to do it again. I'm going to do a quick review. So this is all to kind of just like jog your memory. So you've seen this before. You did in Algebra. You did in Algebra 2. I'm going to move quickly. If you need more in-depth, look at this. Go back and watch some of these. It's Chapter 5 in Algebra. I think it comes up in Chapter 2 in Algebra 2 for us. So the most basic form, or most common form, is slope-intercept form. Why is it called slope-intercept? Because it's y equals mx plus b. M is the slope, and b is the y-intercept. It's also called y-intercept form, and that's why, because you can see the slope. Boom, there it is. You can see the y-intercept. So that's what's nice about this. And it's the one that is probably the easiest way to graph for us. So that's the one we use probably the most often. Let's real quick make sure we're cool with this. If I gave you 2 points, could you do it? Sure. Remember, if you have 2 points, you just use the slope formula. y2 minus y1, or y1, it doesn't really matter as long as you're consistent. Subtract your y's is the change in y on top over the change in x on bottom. So if I do that with this one, I'm looking at something like negative 10 is the y over here, minus 2, over 4 minus a negative 12. So I've got something like negative 12 over what? 16? So if I look at that, reduce that fraction, we got negative 3/4. So my slope is negative 3/4. The key is, how do you find b? Where are you going to get that? That's the slope. So you say, oh yeah, I know the slope is negative 3/4. But how do you find this b? Well, you got to solve for b. Pick either point. This is x, this is y. I don't care which one. Pick a point and plug it in. So y is really negative 10. And that's negative 3/4. What was x? X was what, 4? And solve for b. And this one's a nice one to solve for, isn't it? If I just simply cross this off, that cancels, add 3 to both sides, we're going to get b is a negative 7. So I found b, plug it back in here for b, and write your final equation. We've got y equals negative 3/4 x minus 7. Awesome. Very good, very good. Could I graph this? Is that something I can graph? Sure. Just count down 7 on this. 1, 2, 3, 4, 5, 6, 7. And I want to go down 3 over 4, but I've run out of graph paper, so do the opposite. Instead of going rise down 3 over 4, you can go up 1, 2, 3, back 1, 2, 3, 4. So make sure your negative lines are going downhill. Positive lines go uphill from left to right. So there we go. Excellent. Very, very nice. So that's great. That's one we're most used to. What about standard form, or sometimes it's called general form? This is the general form of a lot of different functions here. So when we get to conics, they'll all take this general form. Ax plus by plus c, or sometimes we solved it for c. Kind of weird. Ax plus by equals c. C is a constant. I don't know if it's positive or negative. It's just some number. So you can put plus. I know it's positive both these. We don't know if it's positive or negative. It doesn't matter. It's just a constant. So how does that look? Well, it looks something like this, and you're like, wow, that's great, but can you see the slope? No. What is this good for? Well, it actually is good for something. Remember this cover-up method. If you took your hand and covered up the x's, could you solve that for y? Sure. If I say, look at just the 3y equals 9, divide both sides by 3, and you get y equals 3. Well, that's cool because that's the y-intercept. So with a little bit of work, you can see the y-intercept. And then what's cool about this one especially is cover that side up, and what happens? You solve this equation. So divide both sides by 2, you get x equals 9 halves, or 4.5. Go out to 1, 2, 3, 4 and a half. You get this equation. So that's pretty cool. We get our intercepts, and then I just connect the dots. 2 dots make a line, 2 points make a line, and we're good to go. So the cover-up method shows us the intercepts. So standard form is really good for finding x and y intercepts. One you may not have used so much in the past is called point-slope form. This one's great because all you need is a point and the slope, and you're done. So we're going to use this one in calculus just to quickly write things. So I use these same 2 points from over there. Remember those 2 points? So we knew that we found the slope already. So let's say I gave you the slope, or you calculated the slope, and you get this negative 3/4. Pick a point. I don't care which point you want, and plug it in. So y is generic. So we've got y minus y1, in this case is negative 10, equals negative 3/4 x minus the x, which was 4. And yeah, we're not going to write minus, that's weird. So this is really y plus 10 equals negative 3/4. Isn't that cool? So we don't have to find b. We are done and done. We know the slope, we know a point, and then we can graph it. So from here to graph it, you could solve it for y and graph it out, or you could just start at the point 4, negative 10 and graph it from there. Or you didn't have to write that way if you wanted to. You could have wrote it the other way. You could say y minus 2 if I pick the other point. These are both the same line. No problem. Either one of these works, so they're both good for point slope form. So that actually turns out to be a nice handy way for a lot of things we do with tangent lines in calculus. Very nice. Killing it. Quick review of parallel versus perpendicular. Remember, parallel lines look exactly the same. Why do they look the same? That's right. They have the same slope. So let's pretend these both had a slope of 2. Those would be parallel lines versus perpendicular lines. Remember, make that 90. And what's cool about their slopes, if this had a slope of 2 like over there, what's this slope of the perpendicular line? It's the negative reciprocal. So you flip the fraction upside down, change the sign, so we're good to go. How does that look for us? Well, maybe I've got this line. You can graph if you want. I want something perpendicular to this, so I say, aha, there is the slope of that line. The slope of that line is negative 2/3. So if I flip, whoa, that was a big eraser. If I flip that slope, or take the negative reciprocal, it becomes 3/2. Change the sign, it becomes positive. My equation is going to have this slope and this point. If I have a slope and point, what's the easiest one? Slope-intercept standard or point slope? Yeah, point slope. If it says point slope and I've got the point slope, I'm going to use point slope. That was a lot of point slope. So we've got something like this. Boom, done. There it is. If it forced me to use one of the other ones, I could just change it, move it around. But that's point slope form, parallel perpendicular. Let's keep this rolling. To the calculator. So let's take a look at this. I've got this data here about sandwiches, about fat grams to calorie. And I want to know, is there a correlation? Is there some kind of correlation between fat and calories? Let's take a look. So we're going to do this on the calculator. So make sure you get your calculator. Anytime I have data, I want to make a scatter plot to see if they're related. So to put data in, you come over here to Stat, and the very first one, Edit. And I have stuff in my list. This is going to be my list. The first one is like my x's is L1. And that's like my y's, L2. So list 1, list 2. But there's stuff in mine. So to do it, come up here where it says L1. See how it says L1? And hit clear. Don't hit delete. Delete actually deletes it. Hit clear. Boom. It's gone. Then come over here. Come up to L2. Hit clear. Enter. It wipes it out. So let's clean out those lists. And now let's put all this data in. And if you want, we can erase here. Who's going to win? Done. Did I get you? I'm just kidding. You may want to pause and put that data in. All right, once your data's in there, what are we going to do? So I want to make a scatter plot. So when we do scatter plots, if you come above y equals where it says stat plot, statistical plots, oops, I get hit second y equals, and I get there. So we're allowed to put up to 4 graphs in here, 4 different kinds of graphs. So if we hit enter, we come in here, and the first thing you need to do is turn it on. So it needs to get turned on, so highlight on. Then if you come down here, you have options. We've got a scatter plot, we've got a line graph, a bar graph, we've got a box and whisker, and a probability distribution function. Then down here it tells where you're going to get the data from. So I definitely want to make a scatter plot, so it's highlighted. This is from L1, L2. If you need to change it, you can change that at any time to whatever list you're talking about. And then you can mark it with a square, plus, or a little dot. I'm going to leave it with a plus, or I'm sorry, a square, and I'm good to go. So if I just do that and I hit zoom standard, it should highlight. Whoa, where's it at? Aha, this is the hardest part again, is the window. It's there, we just can't see it. We're only looking at 10 in every direction. So we got to come up to window and change it. So think about what is x. X is L1, so that is total fat grams. So look at your fat grams. I know the lowest up there looks like it's 5, the grilled chicken light. But I'm going to say 0. The minimum possible is 0. You could have no fat, let's say. Maybe you had air for breakfast or something, an air sandwich. And then what's the highest? Well, it goes to 34. I'm going to just go ahead and go to 40. I don't want to count by 1s. Maybe I'll count by 5s. So there's my x's. List 2, look at total calories. I see one up there is only 260 calories. But again, if I can, I like to see my x and y axis. You could easily put in 250 or 200 if you wanted. I'm just going to go ahead and throw 0 in there. My biggest looking sandwich looks about 590, so I'm going to go to 600, and I'm going to count this one out by 50s. So now when I hit graph, it should be a much nicer picture. Boom, there it is. And now I look at this. Is there a relationship? Yes, this is going uphill. We call this a positive correlation. The more it looks like a straight line or a certain kind of function, we say the stronger the correlation. So this looks like a pretty strong correlation that's positive. That means as you get more fat, you get more calories. You could have it going down and be a negative correlation. And sometimes you have no correlation at all. So that's a correlation. I think there is one there. So what are we going to do with this? Well, old school, we could pick 2 points like I did earlier and come up with the equation of a line that represents it. But how do I know which 2 points are the best to totally represent this? You know, we want them balanced even on top and bottom. calculator knows they're going to do what we call regression, or the least squares line. So, well, if you take stats, this is really cool and interesting. They'll probably explain this more in depth. But what we're going to do is go to stat, and if you slide over here to calculate, it's going to calculate the best fit line. So I want you doing this. We're going to do this a bunch. So this, I'm going to do what's called linear regression. This is finding the best fit line, and it puts it in this format. So hit enter. If you just hit enter, boom, there it is. That is the equation. So it doesn't do mx plus b. It does. This is for stats. It does ax plus b. We could actually plug that in. The slope is 11.731. The y-intercept is 193.85. That's great, but then I'd have to copy that to my y equals. Unless, I'm kind of lazy, I'm not going to lie to you. Watch this trick. Hit second enter, brings up the last thing you did. I'm going to do the same thing, L1, comma, L2. And I'm sorry, L1, L2 are right above the numbers. Hit one more comma. I want to send it somewhere. I'm going to send it to Y1. To get to Y1 is a little tricky. If you come over here to vars, hit vars and Y vars. That stands for variables. And I'm doing functions. So number 1, and then you can choose which line you want to send it to. Now go ahead and hit enter. Runs it exactly the same, but check this out now in your Y equals. Boom, fully loaded, no rounding. That's the most perfect line. So go ahead and send that over there. Way, way nicer. Check that out. When I graph it, it put in the best fit line. Pretty cool, huh? Very, very nice. So we do this so we can model functions. Let's use this to kind of come up with a question here. The Friendly has Friendly's, I don't know if you're the ice cream place, has, or used to have, I don't know if they had to outlaw this monster, grilled cheese sandwich for buns on their cheeseburger. That is brilliant. That is incredible. It had a pretty amazing 79 fat grams in it. Can we use that to predict? Sure. Remember we just said trace? Be careful though now when you hit trace. Look at this P1. That's on your scatter plot. Like you can hit left and right and it's jumping from point to point, like 21 grams of fat is 420. If you hit up or down, it toggles, gets you onto your line. So if I go over here, I want to know 79 grams of fat and hit enter. What? Invalid. Ah, we got a problem here. This sandwich is too big. When you use this trace feature, it needs to be on the screen, and my window doesn't go to 79, it only goes to 40. So to even see this thing, we're going to have to go out to like 100 maybe. 100 grams of fat. Oh my gosh. It's like a couple days worth. Alright, so if I stretch this bad boy out, now I can hit trace and 79. Oops, maybe not. Hit trace and make sure you're on your function. 79, and I get something like this, and now it'll show me. Wow, there it is. So it's way off my picture. I didn't change my Y. It's there. Or I could have gone to my table. This would probably have been easier, huh? And just hit 79. That's much easier. Excellent. But that's 1,120.6. That's amazing. That is fantastic sandwich. Very cool. What if, though, I only knew... let me go back to my old window. What do we have this at? 40? So let's go back to this one. What if I had a sandwich from back here, and let's go back a screen, and I didn't know what the sandwich was, but I knew the calories. So maybe the calories were something like 460. So if that's 460, could I find out how many fat grams? Can I predict it? Sure. Let's go to our function here. And what am I going to do? Well, I can't use my table to get when I know Y. You can't do it. But what I can do is do this little trick. This is a great little trick. Come down here to Y2. Y, remember, is my calories, so put that in there. Put in 460 as your Y. Hit graph. It's going to graph 460 as a constant all the way across. What am I looking for? I want to know when does it hit my line. So if you go to second trace, see how it says calculate up there? We're looking for which one? That's right, intersect. Where do these two intersect? So another great feature here. And it says I'm on Y1. It tells you what function you're on, so hit enter. And then there's Y2. Hit enter again. It wants you to guess. It wants you to kind of go to where you think they hit, because sometimes they'll hit multiple times. You just get kind of close, and it tells you the intersection. So when it tells me my intersection, this means that sandwich has what? At 22.6, so 22.687. That would be my prediction, the fat grams of a sandwich with 460 calories. Fantastic. Pretty cool, huh? So great tool, this regression, or the line of least squares, best fit line. Alright, so I want to know other shapes. I know this is called linear functions, but shapes I want you to recognize. We're going to graph some data, and it may look like this. A lot of data looks like this, quadratic or a parabola. So if you do that, you got to check this out. When I go to stat, calculate, check this out. 4 was linear regression, but what was 5? Oh my goodness, quadratic regression. So if you have a parabola, we're going to use that. We also have cubic regression. We also have quartic regression. Keep it coming. We have another linear regression. They switch A and B. Number 9, natural log. Remember natural log regression? Exponential regression. Power function. We'll do that one later on. Regular log. And then sine curves and stuff like that. We're going to do all that later on, and we'll be good to go. So I want you to recognize just these for now. If I have a square root, remember square root looks like this. Cubic looks like what? This. And Mr. Bean's going to cover this actually a little bit more, these common functions in number 2. But just for now, so we can get through the practice and whatnot. Oops, I just drew exponential decay, didn't I? That's exponential decay. What else is there? You have exponential growth. So things can either grow or decay exponentially. And that brings up a good point. You could have a negative quadratic. That's gravity, man. A lot of all the gravity problems look like that. You could have a negative square root. You could have a negative cubic. Awesome. Very, very good. So those are our functions I wanted to know, and so you can run the right regressions. Alright, so here's a problem for you to try. Let me just get you a little friendly head start here to get going. When I do anything with these years, it works if you put these years in, but you're going to have a crazy big window, and it's kind of hard to see your data. So a lot of times what we do is we say, whatever that first year is, call it year 0. That's the year 0, your initial year. And then everything else is how many years since. So like if that's 1984, 1996 is 2 years after that. 1998 is 4 years after 1994. Then 6 years after, then 8 years after, then 10 years after. So call this your L1 or your X's. It's how many years since 1994. I think that really saves a lot of time when you put that in. So go ahead and try to graph that, answer some of these questions. I'm going to kind of get you started after you, once you've tried a little bit, and then I'm just going to post the answers to the rest. Alright, I got my data in here, and let's go set the window together. So make sure we're good on the window, and then I'm going to post some answers here. So when I think about X's, I'm thinking about the year. Again, remember I'm going from 0 is my initial year. I'm not using 1994. And this is about 10 years, so maybe I'll go 12 years. I don't know, give myself a little breathing room. I'll count by 2. So that'll be my excl. That's what the excl means, is what am I counting by. Y is, I'm going to, again, if I can try to make it 0, I do. I know I could start it at 50. And this goes to like 120. So what's my Y skl? My Y, I'm counting by, I don't know, tens. And I'm good to go. So there's my window. Let's go ahead and put that over here just in case you need it. And let's graph this bad boy. Boom. I got it. What? Aha! I made a mistake. I wanted to show you this error because it comes up all the time. Dim mismatch means this. It means usually, well, I know what it means. It means you were missing a point here. See how down here I forgot to put its partner in. So I forgot its partner here. I left 110 off. So if you get that, it means it's uneven data. Your stat plot can't graph it. What usually happens is you've got something left over in here. And see how this is highlighted up here, plot 1? It's like you're not even trying to graph something. Somebody left something in there and left this turned on. So you can easily come up here and turn it off, and you're good to go. You get rid of that error. So now my plot's off. Now it's on. So now that I'm correct, I figured that out. I have this data. Cool. Let's take a look at this. What kind of data is this? Well, you may have put a line through there. It's not bad. A line would work. It would kind of cut right through there and have a little bit on top and bottom. But this case is actually a very, very wide stretched out parabola. So really what I want to do is take this and do quadratic regression. This should be even better than a line. So how do I do that? Remember this? And you're probably wondering, well, how do I know for sure? If you take AP Stats, they can get more into on why, which one is better. Alright, so I went ahead and posted the rest of the answers here. After you run that quadratic regression, look how nicely it fits through. It hits almost every point perfectly. That's why it's a little bit better than the line. It's getting them all. So when you write that out, yes, it's a pain. I like to go to 3 decimals, and look how long that model is. Boom, there it is. But again, leave it in your y equals, and just use your calculator button so it's exact. I got 185.56, which really means 185,560 100-year-olds in America. Because remember, this is in thousands. And that's the actual year that this will happen. So, hope that went well. I'm going to end with a little dancing Darth Vader. Nothing gets me fired up like dancing Darth Vader. Good luck on the mastery check. Peace out.